Lesson number 93 is about fraction bars as symbols of inclusion. Now a fraction bar, let's use our pen tool, a fraction bar right here is a symbol of inclusion. What the fraction bar tells us is we have to do everything in the numerator first, then everything in the denominator second, before we can reduce our fraction or divide. So let's do that. In this problem, we need to do everything in parentheses first. So we're going to get 4 minus 3 minus 7, that must be negative 4, plus 3 times 2, multiplication comes next, so that's 6, plus 6. And we're going to divide that by everything on the bottom. We've got 2 times negative 4 minus 1, negative 4 minus 1, well negative 4 minus 1 more, that must be negative 5. Now we need to simplify everything in our numerator and denominator before we can simplify our fraction. So we have, well, we've got addition all the way across, and we've got multiplication in the bottom. We can do the numerator first, the denominator second. So 4 minus negative 4, well, the opposite of a negative is a positive, so this is really saying 4 plus 4. 4 plus 4, that's 8. And then we have 8 plus 6 plus 6. We know with the commutative property we can do addition in any order. So we're going to get 8 plus 12, because 6 plus 6 is 12. In our denominator we have 2 times negative 5, that's negative 10. So we can simplify now, because 8 plus 12 is 20, and we're going to get 20 over negative 10. That's like saying 20 divided by negative 10. Well, 20 divided by negative 10, that must be negative 2. And we've got our final answer. Important thing to remember is we have to do our numerator and denominator first when we have fractions and symbols of inclusion and different operations in order to simplify in the end. Let's look at another example. This one looks similar. Let's begin with our numerator. We're going to get 6 times negative 4 plus 3, that's negative 1, minus, and then we have negative 2 minus 6. Well, if we think about our number line, negative 2 minus 6 more, that must be negative 8. And then we're going to multiply that times 2. We can simplify our denominator. 3 times 2 minus 4, 2 minus 4, that must be negative 2. And let's simplify across. 6 times negative 1. That's negative 6. So we have negative 6 minus negative 8 times 2. Well, negative 8 times 2, that must be negative 16. And we're going to divide our numerator by 3 times negative 2. That's negative 6. Negative 6 minus negative 16, well, that's really the same thing as saying negative 6 plus 16, because the opposite of a negative is a positive. So negative 6 plus 16, well, that's going to give us 10. And we have 10 divided by negative 6, because the denominator is already simplified. Let's cut both numbers in half. We're going to get 5 over negative 3. And that's our answer. The way we could write it is this, negative 5 thirds. When we've got a negative fraction, it's always nice to put the negative symbol in line with our fraction bar. It doesn't matter which number is negative, because the whole thing is negative. So we get negative 5 thirds. Now if we wanted to, we could change this into a mixed number. That would be negative 1 and 2 thirds. Both of these answers are correct. I'd encourage you to leave it as an improper fraction. I already know you know how to turn improper fractions to mixed numbers, so doing that step is just a little bit of extra work. But if you like to do that, if this number makes more sense to you, you're more than welcome to. But both answers will get you full credit for this problem. We'll practice this more with our lesson practice on page 291. Make sure you've got your notes complete, and I'll see you during our next class.